Strassen's matrix multiplication. To understand this, before we should understand how actually we multiply two cross two matrices using traditional method. First, we shall understand the traditional method of multiplying two cross two matrices. Let us consider this A11, A12, A21, A22, and this is another another two cross two matrix, that is B11, B12, B21, and B22. So this is the result. C11, C22. How C11, C12, C21, C22 is calculated? Let us understand using the traditional method. So C11 means first row of the first two cross two matrix and first column of the second two cross two matrix. That is, you can just observe A11 into B11 plus A12 into B21. C12, first row of the first matrix and second column of the second matrix. So that is A11 into B12 plus A12 into B22. So what is C21? Second row of the first matrix into first column of the second matrix. That is A21 into B11 plus A22 into B21. Yes. Last one, C22. Second row of the first matrix into first column of the second column of the second matrix. Yes. That is A21 into B12 plus A22 into B22. So this is how we find the uh, answer for the multiplication of two cross two matrices using traditional method. Let us also take a numerical example. 1, 2, 3, 4. Let us consider them as the first array. Similarly, 5, 6, 7, 8. Let us find the answers. So what is C11? 1 into 5 plus 2 into 7. So what is this? 19. Yes. C12. What is C12? 1 into 6 plus 2 into 8. Yeah. This is 22. What is C21? 3 into 5 plus 4 into 7. This is 43. Last one, C22. That is second row of the first matrix and second column of the second matrix. Yes. 3 into 5, not 5, 3 into 6, because second column we have to consider for the second matrix. Therefore, 3 into 6 plus 4 into 8. This is nothing but 50. Yes, 50. So this is the answer that we get using the traditional method of multiplying two cross two matrices. Let us count the number of multiplications. So, number of multiplications: 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 multiplications. Similarly, let us count the number of additions. 1, 2, 3, 4. So we have 4 additions. So in traditional method, we have 8 multiplications and 4 additions. See, this is very important. In traditional method of multiplying two cross two matrices, we require 8 multiplications and 4 additions. So this is very, very clear. Now we will go to Strassen's method. Let us consider the Strassen's method of multiplying two cross two matrices now. See, let us consider the same A11, A12, A21, A22, and here B11, B12, B21, and B22. So we should get this C11, C12, C21, and C22. See, now how the value C11, C12, C21, C22 is got using Strassen's method. That is the speciality of the Strassen's method. He has reduced time for the computation of C11, C12, C21, and C22. How? Let us discuss. So what Strassen has done is he has got formulas for D, E, F, G, H, I, and J. And J. So he derived formulas for D, F, G, H, I, J. He did some mathematical research and he has got few formulas for D, F, G, H, I, J. Using these values of D, F, G, H, I, J, he will compute C11. How? C11 is nothing but E plus I plus J. E plus I plus J. What is minus G? E plus I plus J minus G, that is the formula for C11. So what is the formula for C12? D plus G. What is the formula for C21? E plus F. What is the formula for C22? D plus H plus J minus F. See, what he did was, using the values of D, E, F, G, H, I, J, he computed the values of C11, C12, C21 and C22. Now let us check whether these formulas are proper or not. Because he has given some formulas, we have to know whether these formulas will give proper answer or not. For that, let us consider the same numerical example. 1, 2, 3, 4, 5, 6, 7, 8. Let us compute the answers. Now first we will compute the values of D, E, F. So what is D? A11 into B12 minus B22. Yes, we got minus 2. E, A22. Okay, just observe the values. B21 minus B11. Very good. F value A21 plus A22 into B11. So we got 35. Similarly, G, A11 plus A12 into B22. So we got this 24. For H, A21 minus A11 into B11 plus B12. So we got 22. I, A12 minus A22 into B21 plus B22. So this is minus 30. And the last one, J, A11 plus A22 into B11 plus B22. So we got 65. So we have got the values for D, E, F, G, H, I, J. Using these values of D, E, F, G, H, I, J, we will compute the values of C11 according to the given formula by Strassen. So what is C11? E plus I. What is the value of I? Minus 30. Plus J, 65. Minus G. What is the value of G? 24. So what is this? 90. So we write down 90. C2, C12, D plus G. What is the value of T? Minus 2 plus G, 24. Minus 2 plus 24 is 22. So we write down the value. C21 is E plus F. E plus F is 8 plus 35. 8 plus 35 is 43. Similarly, C22 is D minus 2 plus H, 22 plus J, 65 minus F, 35, which is nothing but 50. So we got the same answers as we got using the traditional method. See, using Strassens also we got the answer 19, 22, 43, 50. The same answers we got using traditional method. You can also verify the correctness of Strassens method by taking different values for the 2 cross 2 matrices. So it works. So what is the advantage now? Now carefully understand. Let us count the number of multiplications. So how many multiplications are there using Strassens method? Number of multiplications: 1, 2, 3, 4, 5, 6, 7. So totally there are 7 multiplications in the Strassens method. 7 multiplications. Let us count the number of additions in Strassens method. Number of additions is equal to, see, subtraction also we consider as addition, because subtraction is nothing but addition of negative numbers. Therefore, subtraction is also considered as addition here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So totally 18 additions are there. So Strassen's method uses 7 multiplications and it has 18 additions. Now, in Strassen's method of multiplying two cross 2 matrices, we require 7 multiplications and 18 additions. Whereas if you remember, in traditional method, we require 8 multiplications and 4 additions. Whereas in Strassen's, we require 7 multiplications and 18 additions. Now, same thing we are summarizing. in traditional method of multiplying two cross two matrices, we require 8 multiplications and 4 additions. Whereas in Strassen's method of multiplying two cross two matrices, we require 7 multiplications and 18 additions. So multiplications have come down from 8 to 7, whereas additions have increased from 4 to 18. Let us take a very simple analogy. I think with this analogy, you will understand what is the contribution of Strassens. See, 8 kilograms and 4 grams, when it is reduced to 7 kilograms and 18 grams, grams are increased from 4 to 18, but kg is decreased from 8 to 7. What will be the total weight? Is it weight reduction or weight increase? It is reduction. Weight has reduced. Even though grams have increased from 4 to 18, just because the kg has reduced from 8 to 7, the weight has reduced. Same analogy we will take for Strassen's method also. 8 multiplications and 4 additions, when it is reduced to 7 multiplications and 18 additions. Carefully see here, the number of additions are increased from 4 to 18, whereas multiplications are reduced from 8 to 7. What will happen to the total time taken? Total time taken has reduced because multiplication takes a lot of time compared to one addition. That is very, very important. Meaning, in Strassen's method, the time required is less than the traditional method. Now, it's a very small saving of time. Na? A very little time is reduced by Strassen's method for multiplying two cross two matrices. A small amount, tiny amount of time is saved by Strassen's method. Yes, a very time saved is very little when Strassen's method is used only once to multiply two cross two matrices. So if you are using Strassen's method to multiply only once 2 cross 2 matrix multiplication, then the time saved is very little, almost insignificant, almost that is very little, ignorable time is saved. The time saved will be more and significant when Strassen's method is used to multiply large number of two cross 2 matrices. Large number of 2 cross 2 matrices, not two cross 2 matrices, large number of 2 cross 2 matrices. Yes. Now, how that happens? Let us consider this 4 cross 4 matrix. A 4 cross 4 matrix can be divided into 4 2 cross 2 matrices as follows. So, let us take an example. This is divide and conquer. What we are saying here is divide and conquer. So, this is the 4 cross 4 matrix. Yes. How to divide this into 4 2 cross 2 matrices? Yes. This is the first 2 cross 2 matrix. This is the second 2 cross 2 matrix. This is the third 2 cross 2 matrix. This is the fourth 2 cross 2 matrix. So this is how one 4 cross 4 matrix can be divided into 4 2 cross 2 matrices using divide and conquer. Similarly, a 8 cross 8 matrix can be divided into 4 4 cross 4 matrices. And carefully understand, each 4 cross 4 matrix again in turn can be divided into 4 2 cross 2 matrices. Similarly, a 16 cross 16 matrix can be divided into 4 8 cross 8 matrix, and each 8 cross 8 matrix can be divided into 4 4 cross 4 matrices, and each 4 cross 4 matrix can be in turn divided into 4 2 cross 2 matrices. That's how divide and conquer happens. Now, consider the multiplication of 4 2 cross 2 matrix using divide and conquer. So let us take a 4 cross 4 matrix. So this is first 4 cross 4 matrix. This is second 4 cross 4 matrix. Now carefully understand, here we are not multiplying individual elements, rather we are multiplying 2 cross 2 matrices. So how it happens? Let us see through demonstration. See, we are taking 2 cross 2 matrix and we are multiplying with another 2 cross 2 matrix of B array. Yes. This 2 cross 2 matrix into this. That is first row, first column. Same thing we are doing. We are not multiplying individual elements, rather we are multiplying 2 cross 2 matrices. So we get this 2 cross 2 matrix and we paste here. That is the 2 cross 2 matrix in C. Similarly, I think you can understand this simple. Yes, 2 cross 2 into this 2 cross 2 into this 2 cross 2 into this. So we get this we here. So I'm using color so that you understand what matrices are being multiplied, what 2 cross 2 matrices are being multiplied. For that, I am using different colors. Again, let us see. Yes, 2 cross 2 into this 2 cross 2 plus 2 cross 2 into 2 cross 2. We get this. This we write down here. And the last one, yes, 2 cross 2, 2 cross 2 plus 2 cross 2, 2 cross 2. We get this. This we write here. I think you should be able to easily understand this. There is no difficulty. It is quite simple. So did we multiply individual elements? No. We multiplied 2 cross 2 matrices. Yes. Now, let us count the number of 2 cross 2 matrix multiplications. Yes. 1. This is the first 2 cross 2 matrix multiplication. 2, 3, 4, 5, 6, 7, 8. So actually here we did 8 2 cross 2 matrix multiplication. Carefully understand, 8 2 cross 2 matrix multiplications. So number of 2 cross 2 matrix multiplication is 8. If we use Strassen's method for these 8 multiplications, the time saved increases because Strassen saves a very little time when it is used to multiply one 2 cross 2 matrix one 2 cross 2 matrix multiplication. When it is used for 8 2 cross 2 matrix multiplication, the time saved increases. Similarly, multiplying two 8 cross 8 matrices using divide and conquer needs 64 2 cross 2 matrix multiplication. Here we saw 8 2 cross 2 matrix multiplication. When it is 8 cross 8 matrices, it is 64 2 cross 2 matrix multiplication. And for all these 64 2 cross 2 matrix multiplication, if we are adopting Strassen's method, the time saved further increases. So carefully see this sentence. If you use Strassen's method for these 64 multiplications, the time saved further increases. Yes. As the dimensions of the matrices increases, the time saved by Strassen's method also increases exponentially. So this is a summary. Carefully understand this. As the dimensions of the matrices increases, the time saved by Strassen's method also increases exponentially. Now, if Strassen's method is used to multiply 2 cross 2 matrices only once, it saves a very little time and it's almost insignificant. Whereas, if Strassen's method is used to multiply large number of 2 cross 2 matrices, then the time saved is huge. Time saved is huge. Now, during the multiplication of two big dimension matrices, we apply divide and conquer to get large number of 2 cross 2 matrices. If you remember, 16 cross 16 matrix can be divided into 4 8 cross 8 matrices, and each 8 cross 8 matrix can be divided into 4 cross 4 matrix, and each 4 cross 4 matrix can be in turn divided into 4 2 cross 2 matrices. Meaning, during the multiplication of two big dimension matrices, we apply divide and conquer to get large number of 2 cross 2 matrices. Then we go on multiplying these 2 cross 2 matrices using Strassen's method. And hence, enormous amount of time is saved. This is the contribution of Strassen's. So in summary, very important, Strassen's method is almost insignificant without divide and conquer. Strassen's method becomes very much significant with divide and conquer. Because without divide and conquer, you don't get these 2 cross 2 matrix multiplications. Number you don't get. So therefore, it saves a very little time. Whereas when you apply divide and conquer, you get lot of 2 cross 2 matrix multiplications. And for these 2 cross 2 matrix multiplication, if you use Strassen's, that's a huge saving. That is the power of divide and conquer. So Strassen's method, when it is used with divide and conquer, it saves enormous amount of time. That is the power of divide and conquer. So that is the contribution of Strassen's matrix multiplication. He reduced the time. It saves time. Now, let us take the time complexity of multiplication. First, using traditional method. So, in traditional method, we know 8 multiplications, and multiplication is the major operation. Also, divide and conquer is used to multiply large dimension matrices. All this we know. So, recurrence relation can be written as follows. So, it is 1 if n is 1, otherwise 8 into 8, because 8 multiplications, into t of n by 2. Because we again divide, we apply divide and conquer. Otherwise, yes. So, we will assume n is equal to 2 to the power of k. So, this is nothing but t of 2 to the power of k divided by 2. We apply indices and we know 2 to the power of k by 2 is 2 to the power of k minus 1. So we write this t of 2 to the power of k minus 1. This we call it as 1. Now substituting k by k minus 1 in 1, we get t of 2 to the power of k minus 1 is equal to 8 into t of 2 to the power of k minus 2. We call this as 2. Now substituting 2 in 1, equation number 2 is substituted in 1, we get, yes, this is what we get. Yes, and this is 8 square into t of 2 to the power of k minus 2. Further, if you continue like that, you get 8 cube into, yes, next 8 to the power of 4. Similarly, at last we get 8 to the power of k into t to the power of k minus k, t of 2 to the power of k minus. So this is nothing but 8 to the power of k into t of 2 to the power of 0. What is 2 to the power of 0? 1. And what is t of 1? T of 1 is 1. This is nothing but 8 to the power of k. Now carefully understand, n is 2 to the power of k. What is k? K is log n. Therefore, this can be written as 8 log n. And this, anyway, you know logarithms, n log 8 to the power of, to the base 2. So what is log n? Log 8 to the base 2, it is 3. Therefore, it becomes n cube. So what is the time complexity of multiplication of 2 cross 2 matrices using traditional method? It is nothing but t of n, theta of n cube. N cube is the time complexity. Now let us see the time complexity for using Strassen's method. Time complexity of multiplication of 2 cross 2 matrices using Strassen's method. So in Strassen's method, we have 7 multiplications, and multiplication is the major operation. And also divide and conquer is used to multiply large dimension matrices. Yes. Recurrence relation we will write down. Same thing, 1 if n is equal to 1. Now 7, because 7 multiplications, and multiplication is the major operation. And same thing, divide and conquer we are applying, same thing. Now 7 into t of this, and again we assume n is equal to 2 to the power of k. So now same thing, indices, so it is 7 into t of 2 to the power of k minus 1. This we call it as equation number 1. Substituting k by k minus 1 in 1 we get, yeah, 7 into 2 to the power of k minus 2. This we call it as equation number 2. Now, substituting equation number 2 for t of 2 to the power of k minus 1 in 1, we get, yes, that is not 8 actually, this is a printing mistake, it is 7. So it should be 7 squared. 7 squared into t of k minus 2. Similarly, 7 cube into t of k minus 3. Similarly, 7 to the power of 4. T of k minus 4. So like that, if you go on, it is 7 to the power of k into t of k minus k. So we get this. Yes, 7 to the power of k. And we know n is equal to 2 to the power of k and k is equal to log n to the base 2. Therefore, we get 7 log n to the base 2. This is nothing but n log 7 to the base 2. And we know log 7 to the base 2 is 2.807. So this is nothing but n to the power of 2.807. So therefore, the time complexity for Strassen's method is n power 2.807. What was the time complexity in traditional method? N power 3. Now Strassen has reduced it to n power 2.807, meaning Strassen has reduced the time taken. And also carefully understand, Strassen's contribution is definitely very huge when the dimension of the matrices are large, and when we use divide and conquer. Yes, Strassens has saved a lot of time. I think this is quite simple. Uh, I think it is completely demonstrated with the time complexity. I think easily you should be able to understand this Strassens matrix multiplication.